Okay, guys. So today I'm going to do some explanation on your lab, right? So we're going to cover lab 3 until lab 6. So throughout my presentation, if you guys have any question, you can stop me. You can ask question by turning on your mic, or you can just type your question in the chat box. So as you guys can see my screen right now, so I'm showing you the lab 3, right? So this is the solution for lab 3. What I'm asking you guys to just modify or to duplicate to add another 7 segment display. So in this case, right, so I'm having 1 7 segment display. So what I did is that I just copy this whole thing and then I paste it. This is going to be my second 7 segment display. But the thing is that I have to use a different variable to control those another or the second 7 segment display. As you can see here, I'm using SEG for the first 7 segment display. For the second 7 segment display, I'm using SEG2, SEG2, right, for the second 7 segment. So the rest are the same. So what is inside here? So this is your control bit, to turn on your LED inside the 7 segment display. So as we can see, most of it is zero for zero number because your 7 segment is active low. Active low means that it's going to light up when you are giving the low signal, which means you connect it to the ground. Right, so when you connect it to the ground, so you complete the circuit, you're giving the current to flow down to the ground and light up the LED. So the rest are the same. So you just change the number. So this is SCG1, this is SCG2. And then the changes of the 7 segment will be based on the input, right? So for the first 7 segment, the input is the BCD. So we just add another one, BCD2. So we have two inputs, right, that control two 7 segment display. All right. Okay, so what else? Okay. All right. So then, okay, let's go to simulation first. Let's open our simulation file. Waveform. Open. All right. So here already, customize the input. So when you want to simulate, right? So you have to know which one is your input, which one is the output. So for an example in this code, right? So my input is BCD and BCD2. So when we simulate it, so we have to assign our input to the value. So that's why we need to understand how the circuit is functioning so that we know what value to assign in this case, right? So I want to see that right now, both of the 7 segments functioning well, right? So based on the input that I give. So I set the BCD input here. Oops. Right, so as you can see up here is a 00001, right? So 4 bit, and then here I vary the input to 10010100, right? Then you just simulate it. So this one you have to assign it, right? So some of you asking me like how can we simulate, right? So you have to assign the input value first, then you can simulate. Then you press this functional simulation button, and then just wait for the result of the simulation to pop out. Okay. All right, so now we have the result, right? So we can check whether our result is correct or not. So you just go and verify. Okay, for BCD1, when it is 000, so the output is 0001. Okay, just go and check, right? So when the input is 0, then the output is 001. Okay, for the second 7 segment, when the input is 1001, the output is 100. Okay, when the input is 1001, which means this is equal to 1, 2, 4, 8. So it's 9, right? So when it is 9, the output is 100, 100. Right? So that's the way you can check it. Then you to verify that, okay, now my circuit is right, it's correct. So that means I can go and load it on the board. Okay, then the second thing is that for the pin assignment, right? So for the pin assignment, I mean, this is just to show you guys later if you guys are dealing with the real board, right? Which is in this case, we are not going to use the real FPGA board. So, but I'm just giving you the knowledge, right? So for in this example, we are using two, right? We are using two 7-segment display. So let's go find this 7-segment. Switch LED, okay, 7-segment. Okay, so if you guys look on the board, right, so we have a multiple 7-segment display. So this is the board. As you can see, we have 2, 4, 6, 8 7-segment display. So we have to know which 7-segment display that we want to connect to the on the board, right? So as you can see here, so this is 7-segment digit 0, which means all this number from 0 until 6 here represent one 7-segment. So this is one 7-segment. And then 7-segment 1 here, 0 until 6 is the second 7-segment. And then here, 7-segment digit 2, 0 until 6 is the third 7-segment. And it goes until 8, right? So you're going to have 7, right? Starting from 0 until 7. So you have 8 7-segment display. All right, so if in this case we are only use two 7-segment display, right? So if you are using two 7-segment display, so we just need to connect according to this pin, right? So just go ahead. Okay, right. So let's say for an example, so BCD 0 until 3, we have to connect it to switch, right? So later I'm going to show you it to you guys. Okay, now we are using, okay, seg 0. So this is our first 7-segment, right? So first 7-segment, okay, digit 0, so AF10, right? AF10. Then follows. Second one is AB12. So you just double click here, just type AB12, then enter. Right, okay, then we complete all these things. So you complete, then you completed the connection, right? Then you have to recompile. Okay, for the switch, right? Same. So you have to check. For example, here is the where's the switches? Okay, this is a switch, right? So toggle switch. So in this case, we need 8, right? 8 toggle switch, because 4 for 7-segment 1, 4 switches for 7-segment 2. So we need to connect it to 8 switches. So you can choose any 8 of the switches from here. So just follow N25, connect it. And then N26, connect it in order, so if for easy to you guys to test it later when you load the program on the board. All right, so for lab 3, do you guys have any question before I proceed to lab 5? Sorry, lab 4.
For now, no, doctor.
Okay, all right. Others? Any question? Okay. All right, okay, let me proceed then to lab 4, right? Okay. All right. Okay. Lab 4. Okay, let's open lab 4. Okay, for lab 4, right? So you guys being asked to all right, to add another 2 module, right? So you have to add another 2 module, which is shift left and also shift right. So in this case, you guys just Google what are the operator that you can use for shifter, right? So they are if we need to create 3-digit number like 100, so the BCD will have 3. Yeah, sure. If you want to display it on 3 7-segment display, then you need to have 3 different BCD code. So you just add another one, right? So, but I think one of the question that you might ask, right? So how we can make a counter, to count up until 2 7 segment. Okay, later I'm gonna just share with you guys. Maybe later you guys need, or you guys want to use that kind of code, right? So I'm gonna show you how you can do that, right? But yes, if you want to create 3-digit number, you want to show it on 7 segment display, of course you need to have add another one, right? The BCD, right? So BCD1, BCD1, and BCD2. Of course, the 7 segment also need to add, right? So you have three always coding, right, in your code. All right. Okay, so now we are going into lab 4, right? So your lab 4, if you guys remember, the task is asking you guys to modify the existing ALU code that I gave to you guys. So what are the things that you need to modify? You need to add shift left and also shift right. Okay, the first thing that you need to do is that complete the shift left and shift right code first, right? So you need to take the input from A input, right? So just one input and shift it 1 bit. So 1 bit to the left and also 1 bit to the right, and then output the shifted input. Right, so here's the code for shift left and here's the code for shift right. Okay, as you already have it, then you need to do some modification, right? What is the first thing that you need to change is that you need to change your what they call it, marks, right? Multiplexer, because as you guys see here, I mean, you can check how your code being connected. Okay, let's open the RTL viewer. Okay, this is to see the connection, right? So as you can see here, all of the operation will go into your multiplexer here, right? So from here you will select which operation that you want, either is adder, subtractor, or multiplier, shift left or shift right, right? So this is your selector, right? Okay, then okay, how you want to make sense, between this block and your code. So that's why you have to go forth and back, right? So this is for you guys to have the idea, the overall picture, how your code has been connected, right? Because I'm telling you guys, because I figure out some of you guys are just copy the code from your friends and try to understand it but don't really understand the code. So for me I think copy is a part of your learning process, right? But there are two types of copying, right? The first one is smart copying, second one is stupid copying, right? So the one that I don't want you guys to go through is stupid copying. Stupid copying is that you just copy it but don't understand it. You finish the job but you gain nothing from it, which is, I think, it's just a waste of time. Might as well you just quit university and go to culinary school, learn how to cook or do something else that maybe you enjoy much better, rather than try to be an engineer, but you don't really, want to put an effort or any sacrifice, to gain knowledge in this area. So I think copy is okay for me because it's a part of your learning process. But copying without understanding, that's the main problem that I think I have with you guys, right? So better you guys work out on it. So try to understand, what you guys are doing, right? So by copying and try to understand it, that then I think you guys are doing some job, right? So you guys deserve some marks. Okay. Okay, now, okay, how we can understand, so between this diagram and your code, right? Okay, let's say you want to understand about this diagram. So what you should do, and then you have to go to the code and check it, right? So it's a marks 32.3, marks 32.3. Let's double click it. All right. Wait, marks. Oh, it's already open. Marks 32.3. All right. Okay, so this is how you make sense what are the code all about, right? Okay, now you see here, right? Okay, now marks 32. Okay, there's a how many input? One, two, three, four, five inputs. Right, so mean the input I0 will be selected if the select is equal to 3 bit 000. I1 will be selected if the input select is 3 bit 001. Right, okay, this is how we try to make sense of it. Okay, now you want to see, okay, what is I0, what is I1, I2, right? Okay, then if you want to know, you have to go to your top level module. All right, what is top level module? Top level module is where all the connections happen, right? So that's why we call it as top level module, right? So this is where all the connection happen. Okay, now look at marks 32.3, right? So this is the code, right? So this is the code and this is the connection that we made, right? So we can see here, add out, sub out, mul out, right? So what are these things, right? So check in the code. Where is this add out? Okay, add out. Where's okay? Add out is here. Okay, add out means that it is a wire. So you are connecting it between a module. Okay, if a wire, that means one end is connected here, there should be another end that be connected to somewhere else, right? Okay, try to find. Okay, where's the add out? Okay, add out, add out. Where is add out? Right. So where is the add? Okay, here is the add out. So the add out is connected to this add 32. Right. So okay, what is add 32? Open add 32. Okay, so okay, no, this is some. It's not going to the correct. Okay, add 32. Okay, this is okay. That means it is added. Okay, now I know, right? So now I know that the input one, if I select I0, that means it's gonna output the addition result. Right, so same goes, then you have to go to look for I1, then I2, I3, I4. I mean, of course, this code I've already modified, right? So previously you just have three, right? Addition, subtraction, and also multiplication. But now I've added the, what do you call it? The shift left and also shift right in the code, right? So if I'm going too fast, please let me know, right? If you guys don't understand any part that I'll try to explain to you guys, please let me know too, right? Else I just think that you guys are fine and you guys are getting a better understanding after I explain all these things, right? So okay, what else? Then go back here. All right, so we know that okay now all the operation is connected to here. Right, so here's our input and here's our output, and here is our selector, right? So this is our selection. So whether we want to select what do you call it which operation that we want to select, whether we want to select what do you call it addition operation, subtraction, multiplication, or shift. Okay, then all right. So done with the code. Any part of the code you guys want me to explain before I go into simulation? Simulation.
No, doctor.
Right. Any of it? Guys, please let me know. Right, don't be shy. Right, because I think most of you guys are asking me to explain regarding lab 3 until lab 6, right? So now I'm explaining to you guys. So I'm hoping you guys are giving me some feedback so that I know whether you guys which part that I think that you think this is hard to understand. Okay, all right. So same thing again when you guys are doing the simulation. You need to assign the input, right? So you need to assign the input so that you see what's happening. So in this case, I'm assigning. So this is first I change it to unsigned. So radix unsigned decimal. Then I set the value. So I just highlight it like this. Then right click. Then value. Then I select arbitrary value. So I assign it to 15 unsigned decimal. Right. Same goes here. 5. Set it to unsigned decimal. Right. So this is the operation. So this is my addition operations, subtraction, multiplication, shift left, shift right, and then this is just the default, right? Okay, now I'm expecting the result. So just click a simulation here, run functional simulation, and then just wait for the result to come up. Okay, now I have the result. Okay, the first one to see the result, right? To make sense of the result, so I mean, just change this output to unsigned decimal so that you can see whether the result makes sense or not. So, all right. So as you can see here, so when we give a value 15, 5, right? So first is addition, 15. Oh, wait, oh, I didn't change this code. All right. So there's some error on this result. I have to change something first. It's okay because the corrected one I've already done in lab 6, right? So later I'm going to showing you the correct result. So basically what happened is that the first one is addition, right? 15 plus 5 going to be 20. Second one should be the subtraction, and then the third one is multiplication, which is correct. 15 times 5 equal to 75. Okay, then here is shift left and here is shift right, right? So if you want to check the output for shift right, so you have to change it again to binary, right? So binary, and then try to zoom in a bit, right? So then we are, and then you have to change this too, so that you see, because we are shifting the A input, binary, right? So as you can see here, correct, right? It is shifting to the left. And then the second one is also correct because we are shifting to the right. Right, to the right. Okay, now we know that, okay, basically our code is functioning okay.
Doctor,
Yeah,
can you explain more about the shift left and shift right?
which part? And the code or
At the output.
at the output? Okay, as you can see here, so we are shifting the input A, right? So we are shifting the input A. So we when we shift it to the left, so as you can see here, all the input is shifted to the left, and then the last bit here will be replaced by zero number, right? By default, that's what the code is doing, right? The operator that we use, right? The this one, shift, right? So the operator here, I mean, it's gonna shift left, then it's gonna replace it with zero. So in this case, all the number is shifted to the left. So for example, one here shifted to the left, one, the second bit shifted to the left, third bit shifted to the left. So everything will be shifted to the left. So the last bit here will be replaced by zero. So everything is shifted to the left. So that's why you see here it's being shifting to the left. Okay, for the second one, shifted to the right. So as you can see, is go against the left, right? So it's moving towards the right. Moving toward the right. Same, the MSB here will be replaced by zero. So everything will move to the right, and then the last bit here will be replaced by zero. Or the MSB will be replaced by zero. Alright. Is it clear? Siapa tanya tadi?
Yes, yes, yes,
Amalia
doctor.
dah? Okay, alright.
Thank
Sir,
you.
nak tanya,
Yeah.
input A tu dia memang kena besar daripada input B kan? Kalau kita buat input A lagi besar daripada, lagi kecil daripada input B, dia akan dapat negatif kan?
It's going to be negative. Yep. Yeah, the answer will be negative.
Lepas tu, dia boleh ke dapat negatif tu? Ke nanti dia akan jadi error apa-apa?
I'm not sure. One way you can do, just let's try it. Let's try it. Tolak is, let's change the whole part. Let's make it, let's say, maybe, oh sorry, this is our result. So, okay, this is a result. Okay. So T-shirt to arbitrary label. Okay, next T-shirt. Let's say make it 3, right? Okay, then function. Okay, doctor, how about shift register? If have shift right and shift left, is it we need to do shift register? Okay, so I think it's sign decimal. So addition, yeah, 3 minus 1. Yeah, but it's not showing in negative number, right? Although this is yeah, but I think still we get it correct, right? So 3, and so it should be minus 2 lah, but it's 2. Yeah. So I mean, just play around, try to check whether, your code is functionally working or not, right? So that's how we verify the result, all right? So is it okay, Amirul? Amiruddin, you get it?
Okay, Doctor.
Yeah. So I think this is our learning process, right? So I mean, when you want to figure out something, right? Just test it. You have the software, you have the code, right? So test it and see whether the result is correct or not. Then you know whether it's working or not. Right. So okay, I'm looking at this question. If you guys have any question, please let me know. Right. As I'm assuming that you guys understand lab 5, then I'm gonna lab 4, then I'm gonna move to lab 5. Okay, how about shift register? If have shift right and left, is it we need to do shift register? Okay, that's what I'm telling you guys. So in designing, right? So what are the thing that concerning us is the output. If you can do it the easiest way, then might as well just choose the easiest way that you can do. So if you can use one line to do the shifting, right? So this is already shift, right? I mean, this is a shifting code. But what's happening inside here, of course, this is a shift register inside, right? But this is to make our life easy so that we don't have, I know, I mean, some of you can find another code, right? So if you Google, right? So let's say Verilog shift register. Let me try to find the code for shift register. Okay, this is one example, right? So where you can do the shifting, but this one, I mean, it's gonna be the same, but the thing is here you can control whether you want to replace the new input with 0 or 1, right? But instead of having like 1, 2, 3, 4 lines, right? So you can just use one line to do the shifting left. So this serves the purpose. So when we are talking about design, we are talking about the output, right? So no matter how you achieve it, as long as you get the correct output, it's fine. Right? So if you can use one line to do the shifting to the left, then it's good enough, right? Okay. All right, Koyum, did I answer your question? Or you still confused? Okay, guys, any other question before I move to lab 5?
No, Doctor.
Right. And the rest of you?
No, Doctor.
Okay. Doctor, example, we do the coding and get the result. How can we know that our output is correct? Okay, that's what I'm telling you. So the simulation part is very important, right? So this is how you check whether you are getting the correct input or not. So for an example here, right? So when you're giving 0, 0, 0, so you have to know first in your code what is the 0, 0, 0. So after I've checked in my code, right? So go into my code, then go into where's my marks here, so 000. So I check the connection, right? So I check the connection, where's my lab 4 code. So I know that okay, the first one is addition, right? So addition, second is subtraction, multiplication. So I understand my code first, right? So after I understand my code, then I assign the value into the simulation. Then I look at the output, right? So for this example, so the first one is addition. Okay, my input is 5. For my input B, my input A is 3, right? Okay, for the first part is addition. 5 plus 3 is equal to 8. Then, okay, I look at the answer. Oh, 8. So it's correct. 5 times plus 3 is 8. Right, so second is subtraction. So, 3 minus 5, it should be minus 2, right? But it's 2, is correct, right? And then the third one is multiplication. 3 times 5 is equal to 15. Right, so it's 15 is correct. Right, then I verify, okay, now my code is working fine. Of course, you need to verify all those operations, shift left, shift right too, right? Okay, Kamel. Okay, Atira, doctor, the input F just create. The input F just create. What do you mean just create? I mean like the input F just create. Wait, can you clarify what is your question, Atira?
Like the input A and input B, we are putting the number, right?
Okay.
Then for the input F, how do we know the answer? How it related with the A and B input?
Oh, okay. So if you now check, right? F. Okay, first, okay, now we check it. Okay, let's go into our diagram here, right? Okay, so F, here's your F. So see where's the F being connected. Okay, then we see, oh, F is connected to the selection of the marks, right? Okay, what is the F is really doing, right? So let's look in marks 32.3 code. Okay, let's go into marks 30. Marks. Okay, this one. Okay, oh, okay, there's a selection input here, select, right, which is we connect the F. Okay, what is the select is being used for? Oh, is to select which operation that we want to execute. Okay, so we can see here, so select, okay, is choosing, right? So based on the select input here, either is 0, 0, 0, 0, 1, we are selecting which operation that we want to output the result, right? So either this one, I0, I1, I2. Okay, how you want to know I0, I1, I2? So look in here, right? So this is how you connect your marks 32, right? So here's how you connect it in order. I0, I1, I2, I3, right? So I0, I1, I2, I3. So I0 is addition, subtraction. Okay, look here back. Okay, you know that when you set your F equal to 0, 0, 0, that means you are selecting the addition, or 0, 0, 1 is your subtraction. 0, 1, 0 is your multiplication, right? So that's how you verify it. Then you know, okay, that means my F input is to select which operation that I want to do, right? So I have to assign it, right? So I assign it to check the operation, right? So first you assign it 0, 0, 0. That means represent operation addition, right? And then you assign it to 0, 0, 1 for subtraction, and you assign it to 0, 1, 0 for multiplication, and the rest, right? For shift left and also for shift right. Okay, then you simulate it. Then you simulate it, okay, then you see the result, okay? Then you know, okay, 0, 0 is addition. Then you check 5 plus 3 is equal to 8. Then you know it's correct. Okay, that's a follow-up question. Like example, so we get both correct for addition and subtraction, but we can't get for multiplication and division. So where can we see our error and mistake, and how can we solve it? Okay, if that's the error, right, so that means there's something wrong with your code. Right, so you have to look in your coding, right, because there's a connection that I've changed in the code, if you guys remember, right? So yeah, try to make sure you are selecting the 3 input here, right? And 3 input, exactly 3 inputs to choose all the operations. So as you already make sure all the connections is correct, then you should get correct output, right? So to answer your question here, if you can get the correct result for multiplication and division. So it might be something wrong with your coding, right? Your connection or whatsoever. Maybe it's not representing the real operation that you guys choose, right? So try to change your code and try to see your result. Then from there you can verify whether you are you are doing it correct or doing it right or not. Right, Kamil? That's how we debug, right? So we simulate, then we found out, okay, the result is not right. Then we look into the code, which part that we think might be that caused the error, or it's not the error that you cannot compile the code. You can compile, but you are not getting the result that you expect. So based on our top module, it will go one by one in the coding. Okay, clarify your question. The process, I mean, clarify. I don't understand your question. Based on the top module, we go one by one.
So maksudnya kan kita ada apa kat top module tu adder, lepas tu subtractor,
Okay,
multiplexer. So
okay,
dia akan pergi kepada one by one kan?
yes,
Ikut kepada coding kita buat.
yup, according, yup. So
So
whatever you code, then that's what you get in your result.
so kalau saya tak dapatkan multiplication dengan division, maksudnya saya ada error kat tempat sana.
So it can be either your connection here, top level module, or might be something to do with your operation. So I mean, how you can verify, right? So maybe because as your code is getting bigger, right? So you want to verify whether, okay, is this multiplication code correct or not? So you just create one project and just one module here, and then you try to simulate it. Then you see, oh, I can get it correct here, right? So, but when I try to compile the whole thing in this project, right, I'm not getting correct, right? So you know that, okay, you don't have problem with here. Then you know, okay, might be something wrong here in the connection. And then look into the connection. Boleh, Kamil?
Boleh sir, tapi bila kita run kita punya coding tu dia tak keluar error, tapi bila kita stimulate tu cuma kita tak dapat jawapan yang kita
Yeah.
perlukan untuk multiplication je lah.
Yeah, that's correct. It can happen. So that's the function of simulating our result before we load it in the real board, right? So that's the function of we simulate it first, so that we know that we are getting the result that we expect. If we don't get the result that we expect, that means something wrong in our coding. So that means we are maybe we're not thinking it the right way, right? So you have to check again. But that's how, I mean, in the debugging, right? So debugging, you have to break it into small pieces so that it's easy to find the bug. The bug is where the problem of the code occur. So maybe, okay, let's say you want to check, okay, so let's say example, right? We have a problem in the multiplication result. So you can go and just, create one new project, just have one module here to check whether this module multiplication function as you want or not. So if you found out, okay, then okay, no problem with the module. When I simulate it alone, I can get whatever result of multiplication that it gives. So that means, you have a problem in your connection. So just check through your connection. So this is how you debug lah. So you break it into small pieces and try to find where the problem is.
So we try an error to find the connection is correct or no, right sir?
And not try an error. If you understand the code, you can see, you can check the connection, right? So whether you're connecting it to correct source or not, right? And then after that, you try to compile, try to simulate it. Yeah, I mean, you have to know where to change, right? Then of course you try, and if it doesn't fix your error, then try to change, try to do another thing, until you solve the problem. Right. Okay, guys. Any other question before I go into lab 5?
No, doctor.
All right,
No,
good.
doctor.
Okay. As usual, two top student, right? Amal and Hidayah. Okay. All right. Okay. Okay, I think so. Lab 4 is good, right? Okay, now let's go into lab 5. Not open 5. Open project. 5. Okay, now lab 5, right? So, oops, lab 5 is that we try to combine whatever you guys have done in your lab 4, but now we are adding the, what they call it, the counter, right, to control the changes of the input. So right now we don't have the F anymore to select which operation that we want. We replace it with a counter, right? So as you guys see, this is my top level module for lab 4. So what I did is that I add, right? So I add the input for the control, which is clock, reset, right? Clock, reset, what else? And output the ALU control. So this is just want to show which ALU control that we are processing so that we can make sense. We can check, our output is based on which operation. All right, so the rest of the thing is that right now, I mean, if you guys can see, so this is from exactly here from the previous one, right? So here's from the previous one. As you can see here, I mean, I've removed 2 modules here, which I think we are not using the function here. As you can see here, I mean, there's additional marks, which I didn't change in lab 4, but I changed it in lab 5. Because here, I mean, this is the purpose of having this block is if we have a carry input, right? Which is bit 1. So it's a 32-bit inputs, and the input is only one value, which being used for the carry input. But we are not using it, so what I'm doing here, I'm removing it so that we are not using the marks here, right? So the rest are the same from lab 4, and here is from lab 5, right? I think I've shown to you guys this part of the code in my video. So you guys can just move it into one top level module, and we connect the whole thing in one file here. Right, so okay, and then what are we doing here? All right, the first one here is the clock. Here we are just increment the number, right? We have 3 bits of input. We have 3 bits of output, which is our what do you call it? Rack here, right? So wait. Okay, sorry, our out, right? So this is our output. So we have 3 bit size, 0 to 2, 3 bit size. So it being incremented one by one at each positive cycle. So the output of the clock will be connected to our control. All right, so select, right? So select is input. So select being connected to the clock. So how can you verify it? You can check here. Control, see wire 1, right? So this is wire 1. So the output from the clock is wire 1 and then connected to the input of the control 1, which is wire 1 here. Right, so here is your control, right? So in this case, here in the control, we are just choosing one operation, right? One operation at a time. But in the real case later, right? I mean, you can, wait, let me open this file. Lab 6. Okay, later if you guys see here in the state, right? So for example here, so this is lab 6, later I'm going to explain it. So you can put a lot of condition, right, in each state. So you can add additional things, to control your design. So here, if you guys are doing your mini project, here is the code that you need to modify. So this is your control section that we control all the changes that happening in your design. So in this case, we just change the operation, right? So we are choosing addition, subtraction, multiplication, shift left, and also shift right here, right? So we are combining. So we combine all these things into lab 5, right? So you can see how the connection looks like here in RTI viewer. Hey guys,
Doctor,
yeah.
nak tanya yang control ni dia control untuk operation tu je kah?
In this example, right? In this example, we just control the operation. But later in your project, right? Of course, you're having more control, right? Let's say
So-
you have a register. Macam let's say you have a 6 register. You can choose which input of the register that you want to select for the operation. Example. Okay. Proceed. Question?
Kalau ini kefahaman saya, kalau control untuk control operation, while the counter tu untuk kita count setiap masa output tu keluar ke macam mana? Untuk tu counter tu keluar atas sebab hari tu doktor suruh tukar jadi counter kan? Counter and
Yeah. Basically, this is counter lah. Okay. Alright. That's a good question. Okay. For example, okay, this is basic one, right? So this is basic one. The changes just happening every clock cycle. Okay, but right now, okay, let's say we want to change, right? We want to make each state, for example, right? Okay, the first one, right? So let's say case one, which is the first state. So let's say the first state we want to make it, let's say 10 clock cycles. So you have to modify here. So every 10 clock cycle, then you increase the output. Right, so positive age, you need to add another counter, count until 10. I mean, I've covered it in the lecture, right? So how you can do that part. So let's say you do 10 clock cycle, then you increase the output. Right, then another clock cycle, then you increase it. So what happens is that each state will have 10 clock cycle, right? So that you can do anything, if you need more than 10 cycle. For example, if you have washing machine or whatsoever, right? So that's how you can manipulate, right? So that's why, although actually you can just have one block like this, right, to implement all these things, but we want to have it automated, and then we want to work in separate file so that it's easy for you guys to modify later for your mini project. Boleh tak?
boleh
Ah.
boleh faham. Thank you doktor.
Alright. Okay, any other question, guys, before I go into the simulation? But if you guys have any question, you can just type it or you can ask question, right? Using your mic. Alright. Okay, in this case, I've set the value, right, to 20, A, and then B is 5. Right, so reset, I set it high because our ALU will only operate when the reset is high, right? And then here is a clock cycle, right? So ALU control is our output and R is our output of the operation. Okay, now just click the run functional simulation. Okay, now we get the result, right? Okay, as usual, first we just check the result, right? So just change the radix to unsigned decimal. Okay, alright, so the input is 20. So when the operation is addition, right? So 20 plus 5 is equal to 25. Okay, then second one, 001 is our subtraction operation. So 20 minus 5 is equal to 15. Then multiplication, 20 times 5 is equal to 100. Okay, now shifting. Okay, shifting is, the way you want to check it, you have to change the radix into binary, right? Then change A into binary to binary. Okay, now zoom in. Right, so our input is 10100. So here is a shift right, 1010, and then here is shift left, right? So it's correct. And then we verify, okay, then our code is working fine, right? So this is for lab 5. All right, guys, any question for lab 5 before we enter lab 6? right? So this is our block diagram, right? So we can see there's an addition of two blocks, which is our clock and also control, right? So the clock, we know that we have two input here, which is clock and reset, and it's being connected to control. And finally, the control is the one that connecting, that selecting, right, which input that we want. And then of course we connect it to output to observe the output to verify we are getting correct ALU control based on our selection based on clock and also control block. All right, okay, any question for lab 5 guys before we go into lab 6?
No more, sir.
Okay, good. Rest of you guys, any question? Okay, wait. Shift right, it add 0 beside. Shift left, it put the 0. Yep, correct. Shift right. Okay, shift right. Shift right. This is shift left. This is shift right. Okay, shift left. Shift left, right? So we are moving it to the left. So the LSB will be replaced by 0, right? We are shifting everything to the left and we are adding 0, right? To replace the last bit here. For shift right, we are moving it to the right here. So everything from the right here will be kicked out, right? So you see it no more. And then here, the one that's going to replace the MSB is also 0. So left and right will be replaced by 0. So that's what the code is doing. All right. Okay, any more question? Just ask question, and there's no such a stupid question, you know. So every question that can help you guys to understand it is okay. It's a good question.
No, Doctor.
All right. Okay. No question, then let's move into open project. Okay, this is the last lab, right? So it's going to be lab 6. Okay, all right. So, you know, for lab 6, I just try to give you guys, you know, this is what I expect from you guys. So this is the simplest way, right? Because you're saying the pattern and just give input for 4 bits and then you just try to detect the pattern, right? So this is the pattern that we're looking for, right? But there's another code, right? Which is you have one input, then you try to capture if there's a sequence of patterns 4 bits that form a pattern of 1011, right? Which is, I think is okay to do it, which is cool. I think if you guys can do it, so it's also acceptable. All right, so there are two different way you can do it, right? So the first one is by having one input of 4 bits, then try to detect if you have any 1101 pattern here, and then if you guys detect it, then output 1. Or you can accept 1 bit at a time, try to read the pattern. If there's a pattern of 1011 in sequence, then you send it to high output, right? So both way we get marks, right? Don't worry about that. Okay, now I'm showing you guys examples. So I think this is the simplest one for you guys to understand. So this is I'm using more, right? So I'm not showing you guys a milli example. I'm just showing one example. So I'm using more FSM, finite state machine. So what I'm doing here, so you see, I mean, there's actually only like 2 state, right? 0 and also 1. But there's a like intermediary state for more because we know that there's a purpose of having there's a difference between more and also milli, right? Milli is a direct immediate effect, but more there's a delay of 1 cycle before you see the effect. Right, so what I'm doing here, okay, right now, so you see in the first state here is checking the input, right? So if the input is 1101, which is the pattern that we try to detect, then go to the next state. Else, whatever the rest of the input, as long as it's not 1101, stay in this state, right, which is state 0, which is the output going to be 0. If you see this value, right, 1101, then what happened? I didn't delete the comment here, right? If you see like 1101, what happened is that, I mean, in the next cycle, if you see another 1101, right, if you still see 1101, then go to another cycle, then you see the output will be high, right? So the output in our case that we're looking for is Z, right? So the output of the Z will be high. Okay, let's go into the simulation part. Okay, here if you guys see here, I'm purposely doing 2 example of 1101. In this case, I'm doing 1101 at 2 clock cycles. Right here, at 2 clock cycles. And here I'm doing the 1101 at 1 clock cycle only. Right, because we want to see the difference, right? Okay, now let's run the functional simulation. Yeah, the input you have to set it, right? You have to set it on your own. I mean, the easiest way to set your input is you can do like this, you know, right click, select entire waveform, and then value. Then you can choose random values at fixed intervals. So my clock is 50 nanoseconds, right? So I just type 50 nanoseconds. Then I just click OK, but I don't want to click OK because it's going to change some of the value that I do it customly. So it's going to save your time because it's going to set the random input for you guys. So you don't have to set it one by one, all right? Okay, let's see the output. Right? That's the output. Okay, here's the output. Okay, as you can see, for more, right? For more, you need to remain for 2 clock cycles, then you're going to see the output. If you just do it for 1 clock cycle, 1101, you're not going to see any high, right? Okay, that's more. But for milli, as long as it see 1101, immediately you're going to give 1. So here you're going to also see 1. So that's for more, right? All right, so I think that's for lab 6. Any question, guys?
Doktor,
Yeah.
for the simulation kan, boleh tak doktor terang macam mana dia boleh jadi dia trigger dekat naik satu tu dekat belakang?
Kat sini. Macam mana?
Macam mana dia boleh naik satu dekat belakang? Doktor terang daripada awal macam
Okay, alright.
kita kosong tapi macam tu kan.
Okay, alright. Okay, so I'll try to explain that. Okay, wait. I'll answer Amaliana first, then I'll go to Faris Azimi question. Okay. Alright. So okay. Okay. How we can get 1 here, right? Okay, let's look into the code. Okay. Whatever the state will begin, because here it's going to check the state, right? The state value. So as we can see here, our state here is register 01, which is 2 bits. And if we don't initialize it, that means it's going to start from 0. Okay, when we start at the first clock cycle, right? At the first clock cycle here, the state is 1. The state is 0. So when state is 0, is go here, 0, right? So when it's 0, then it's begin. So begin, then we set the output equal to 0. Then we check our input, right? So this is the input that we assign. So the first one, it check the input. So it is 0 at the clock cycle here. It check the input 0, 0, 0, 1, right? So I mean, it's not that we are looking for. It's not the input that we're looking for. We're looking for. So it's not the same, right? So it's not the same. It doesn't go here. It goes here. So next state is equal to 0. So that means it's going to go out. The next cycle, case state. So state is still in 0. Same goes, right? So it goes up until here, until it here at this clock cycle, right? At positive edge of the clock cycle, it detects, right? It detects 1101, right? So 1101. So now it detects. So at this clock cycle, it detects. So the input is 1101. So next state now is equal to 1, right? So at the next clock cycle, right? You're going to go to this state here. Again, it's going to check the input. So this is your, oops, let's look at the output, right? Okay, this is your next clock cycle. So that's why as you detect 1101 here, right, it's not, the output is not 1 yet, because you are still here. When you here, you see the output is still 0. Right? So as you go and check the condition, okay, now we find out the input is still 1101, right, for the second clock cycle. So for the second clock cycle, as the input is 1101, so the next state is equal to 2, 2, 1s, right? So here, then you're going to go out here. So when we go in this state, then the output is set into 1. So that's why we see here at this clock cycle, we already move into this state. And then the output is already out because the output is equal to 1. Okay, then what happened at the next clock cycle, right? At the next clock cycle here, we check the input. Now the input is 0101. So it's not 1101. What happened is that if it's not 1101, next state will be 0. Then you go back to 0 state. Boleh tak, Aman?
Boleh. Thank you, Dr.
Okay, alright. Okay, then Muhammad Farid Azim, if the input is not at positive clock cycle, it can still show the result if the input is not at the positive edge of the clock cycle. Okay. Let's say here, right? So you want to see what happened, right? So possibilities. You can try to change it, I mean, just experiment it. So you want it to be like this, or I mean, you want it to be half here, or you want it to be, okay, maybe I think you, Faris, okay, let's set the value, right? So arbitrary value, okay, let's say it's not 101, so let's say it's like, so 1011. You mean like this, Faris? Okay, let's simulate it and see what happens. See? Nothing happened. So it has to be at the positive edge. So it's reading the signal at the positive edge. Alright, Faris. Is it answering your question? Okay, alright. Okay. Yeah, that's why I mean you have to, try and error, just play around. Alright guys, any other question for lab 6? For milli, why my output is high for 1 clock cycle only, but I fix the input for 4 clock cycle, it doesn't continue high. Okay, I have to check your code, alright? Right, so I mean, we have to look at your code, then we can know what's the problem that you are facing. Right? Okay guys, any other question? The input is set by ourselves, or the next input is followed by the output. The input is set by ourselves, or the next input is followed by the output of zero state. The next input is no. In this case, the input is set out. I mean, we set it. Right? Wait. I'm not sure. Am I answering your question? So as you can see here, all the input we set it, right? So the input is changed based on the user's input. Okay, the thing is I didn't prepare for milli. For milli, I think is just the same. There's the code. Okay, here. This one's complicated. This is more, and here is milli. Right, same. If milli, right? So what you need to do is that you have to modify, right? You have to modify the input, and so check the condition here. Okay, you change the condition here. So if the input is equal to 1101, then go to the next state. Right? Go to the next state, then the output is 1. Right? Check it again here. So if the input is still 1101, then you set it high. Right? If it's not 1101, right, else begin go to state 0. So it's exactly the same. We just change the input here. I mean the first input is 001, then it's not equal to 1101. So the out is 0. Then the next state will be going to back to 0. Yeah, correct. Yeah, that is correct. Right, so if the input is 001, then it's not equal to 1101, then so the output is 0, then it's going to stay in the 0 state. Correct. Alright, so Meijing, may I see the output for milli? So if milli, right? So milli immediate, as long as it's C1101, if it's gonna get the output gonna be 1 here, right? So there's no delay on milli. All right. Did I answer your question, Wei-Shen, and also Meijing? Wei-Shen. Then the next input will back to 0. No, the input will not change based on the code. The input will change only based on our input that we set. Right? I mean, yeah, it's gonna only change based on the input that we set. Right? The state will change based on the input. Right? The state here. So where are we, right? In this which state 0, 1 or 2. So this will change based on, will be changed based on our input. All right. Question, Meiji, did I answer your question? Okay. What about Meiji? So example, right, for Meijing, right? I mean, your question is that let's say we are using milli. So in this example here, so here we have 1101, and the first clock cycle is already 1. If the output of milli will get half clock cycle, the output of milli will remain for 1 clock cycle. Will remain for 1 clock cycle, right? From the high beginning until the other high. Right? So this is one complete clock cycle from here to here. Can we know how the reset work in real hardware board? The function. Okay, wait. Okay, wait. How can we know how the reset work in real hardware board? So, so you know, the code will function as what you are doing the coding, right? So sorry, the hardware will function as the software that you set. So for an example, here in this case, right? So the reset. So where's the reset? Okay. So the reset here. So if at any clock cycle there's a reset, then the state will be going to the zero. Okay, let's go into the diagram here. Okay, right now here, right? So at the first clock cycle here, and we detect the pattern, right? So as we detect the pattern, what happened is that it's going into state one, right? So let's say at here, then you press, right? So let's say here uh, you press the reset button. Okay, let's do it here. So, okay, let's. Okay, let's change back. This is all. Let's change the input here. One 01. Okay, so we change from here now. Okay, so let's say we reset here. We reset here. Right. Okay, let's see what happens. So by default, it should we should have high at the output here, right? But now we press the reset button. Let's see what happens. So basically, what happened on hardware is gonna be the same, like what happened. See, as you press the reset is high, right? So you press it here, then what happens is it's gonna reset the state, right? The state gonna reset into the other state. So it's not going into okay. What happened here is that so it detect 1101, right? So it's going to this state, right? So what happened then you press reset here, and you press reset here, you change the state to 0. It's gonna go back here to 0. Then it detect again 1101 at the second clock cycle, then goes here, but then at here it's not detecting 1101 anymore, right? Because it's detecting 0101. So that's why you see here output is 0. Okay, why more need to detect 1101 two times? Because this is the design, right? So this is the difference between more and also milli. Right, for milli is immediate effect. For more, you need to the input to be the same for 2 clock cycles, then you're gonna get the output. So this is the design. So this is the main difference between milli and more. So if you guys being asked a question, what's the difference between milli and more? So this is the difference between milli and more. Of course, it serves a different purpose or different function. All right. So for imaging, right? Okay, you want to see. Uh, okay, let's do for milli, right? Okay, if you guys want to see milli, right? So let's set it here. Six. Six. So finish. Then Verilog. Right, so go to the code and just copy the code. So this is our milli code. this is melee 1. Alright. Alright, so input. So first we have to change the input first. So the input has to be 4 bits. So input equals 0 in is 1. Alright, so if in equal to 4 bit 1, other 1101, 1101, it's 1, so if, if, this one is like, yeah, so if and go here, so output 0. Wait a minute. Maybe so one here. So here is okay. So this is the state. Let's take 0, 1. So if it is we detect here, then it's gonna go into next state is 1. Right? So what happened here is 1. And so if in equal for bit 101, right? Bear with me again. So I'm working on this melee. Right. And we use term delay for more. Can we use term delay for more? What do you mean by delay for more? Okay. So if we detect 1101, then we're gonna go to next state, right? So here we are in the next state. Okay, so what happened is that as it goes into next state, right? So as it goes into next state, we have to change the output. So the output should be 1 here. Else it's next state, so it's remain here and the output is 0. So when we are here at the state here, so if the input is still 1101 begin, so next state is 1 and the output is 1. Else if it's not 1101, it's going to go, the output going to be 0 and it's going to go into this state. Okay, save. So let's okay, let's try to confirm. Okay, so what's the error that we have? Oops, equal to n plus n 1 with d n. Okay, if we have more than 1 here, we should have a begin. So we have a begin here. And we have Yes, within. Alright. Okay. Can we use delay? Faris, explain your question. I don't understand. What do you mean use delay to describe how more works?
What I'm trying to mean is because more we have to detect two clock cycles for it to trigger, right?
Okay.
So can I say that more is to delay the cycle?
We
It's
don't
more to
delay
delay the
this.
cycle.
Delay the cycle. You're not delaying the cycle. You are delaying. You are delaying the output. You are not delaying the cycle. You are delaying the input. Right? Boleh tak, Chris?
Also, we are delaying the output lah.
Yeah, we are not delaying the cycle. The cycle goes on, right, as usual. But the output is the one that we delay by one clock cycle.
Okay, thank you.
Alright. Okay, now finish it. Okay, let's do the simulation. We want to detect. Okay, let's see. 7. Random. Fix interval. So we're looking for 110. Okay, we have it here. 1101. Okay, let's make 2 cycles for 1101. See what's the effect. Return 1101. Alright, okay, now let's do the simulation. Yes. Alright, okay. Let's look at the output. Oh yeah, so okay, yeah, let's see the output here. So it's just remain for half clock cycle. Yeah, you are right. But why is it happening like this? Positive H on this case. Oh, so there's always case here. So in a state, so the state be updated. This is positive H. Let's go for it. Okay, so as it detects 1101 at high clock here, right? So the output gonna be high, but as it goes down here, then the input. Okay, so what happened is that, so in this code, what happened is that the state. So what's the state? Okay, what happened here is that the state is changes. What I call it? It's not based on the clock, right? So as long as the input change, right, it's gonna detect it. So as long as the input change, see, as the input change out immediately is going to change the state. So because why is just remain for one state? Because it, you know, the changes is with happens with it's not based on the clock, but here with additional changes as the clock is on. Anything else? What next screen? Oh, so I think it happens. Wait a minute. So, there's a second one. Always input or state changes. Yeah, I think because that's the main difference, because the input does not is being updated two ways, right? So it can be updated directly from the always condition here, and the second one is also going to be updated by the clock here, right? So that's why you see here, and when the input changes, right, immediately the state will change, right? And then for the second case here, the input is not changes. So that's why there's no changes here. But the thing here, as the clock cycle positive here, as a positive clock cycle here, then it's going to check the state. So as it check the state, right? So as it check the state, then it realized that the input has changes to 1101, and then that's why the output is high here. Yeah, I think that's the explanation. Or I mean, you can change it too, right? If you want it to remain as one clock cycle, so you can just add clock here, right? So I think that's going to change the output. Yeah. Okay, I think that's the explanation for maging. All right. Is it maging the one that asked the question? Is it answering your question, maging? Okay. All right. Okay. There's a live lab session, right? So really doing the lab during the online lecture. All right. Okay, guys. Any other question before we end? We already have reached the time, so 5 p.m. Right?
For now, no, Doctor.
Okay. Let's stop the recording.